Hey guys, the topic of my lab assessment is tactical analysis on the factors influencing sleep efficiency. My name is Darren Changfaran, student ID 0369793 from Group 21, and I'll be doing correlation analysis. I'll first run Shapiro test to check the normality of the data. And from the result here, it shows that all the p-values are below 0.05, which means the data is not normally distributed. I then run a correlation test to check the relationship between independent and dependent variable, where the dependent variable is sleep efficiency. And from the result, it shows that age and deep sleep percentage have positive correlation, while REM sleep percentage, caffeine consumption, and exercise frequency have weak correlation. While light sleep percentage, awakenings, alcohol consumption, sleep efficiency have negative correlation. And I'll then do data dot matrix to ensure that the data is in matrix format for any map function. I then feed the multiple regression model with sleep efficiency as the dependent variable and age, gender, sleep duration, sleep REM sleep percentage, deep sleep percentage, awakenings, caffeine consumption, alcohol consumption, smoking status, and exercise frequency as the independent variable. I then run VIF value to check the multicollinearity of the data, where the result shows that all the values are around 1, which is less than 5, meaning that the multicollinearity is low and the significant overlap won't really occur. And lastly, the summary model to get the model summary. And here we do hypothesis testing, where p-value less than 0.5 indicates that we reject the null hypothesis, as these variables have a statistical significant relationship with sleep efficiency predictor. Otherwise, we fail to reject the hypothesis where these variables are not significantly associated with sleep efficiency. From the result here, we can see that significant predictor include age, REM sleep percentage, deep sleep percentage, awakenings, alcohol consumption, and smoking status, and exercise frequency. And while significant predictors are gender and caffeine consumption. Next is residue standard error, which shows how much observed value it deviates from predicted values on average. Smaller values indicate a better fit of the model to the data. As you can see, the value here is 0.060063, is very small. While multiple roots R squared show how well the regression model explains the observed data, which is 80.3% model explain of the variation in sleep efficiency, indicating a good fit. And it's adjusted R squared, which is 0.799. After adjusting for the model of predictors, the model still explained about 80% of the variance, confirming its robustness. While lastly is the F statistics, which is 180.3, significantly higher than p-value, showing how significant this model is when predicting the predictors. In conclusion, this lab assessment involved using statistical programming in R to perform the data analysis, including EDA, correlation analysis, and multiple linear regression with hypothesis testing. Through this project, we demonstrated our ability to analyze and interpret data to identify issues within the dataset and apply statistical technique for making inferences. This enlightened us to derive meaningful insight, and presentation showcase our understanding of the concept and our ability to communicate findings effectively. That's all for the lab assessment. Thank you.